Welcome back, everybody. In this section, we're going to continue our work with logic statements by building truth tables. And truth tables allow us to explore the different outcomes for a given logic statement. So let's jump right in. So let's start by defining a truth table and giving an example. A truth table is a complete listing of all the possible outcomes for a compound statement. So the best way to do this is with a simple example. Let's create a truth table for the conjunction P and Q. So to do that, we're going to start by creating a table with a column for our statement P and another column for our statement Q. I like to do this on graph paper, but you certainly don't have to do that. So one of the simple statements that we have to consider the condition of is P and the other one is Q. Now what we want to do is we want to list every possible combination of true and false for P and Q that's possible, but we do this kind of systematically. The first possibility is that they could both be true. Another possibility is that P could be true and that Q could be false. The next possibility is that P could be false, but that Q is true. And the last possibility is that they are both false. Now, these aren't in any random order. As a couple of principles, we always describe the condition of each statement as either true or false, and we always list the true possibilities before the false possibilities. That's why we started with both being true, and then the first one true but the second one false. Then our two false conditions for P where Q is true and Q is false. So for any compound statement on two simple statements, P and Q, the pattern here will always be the same. P will be true, true, false, false, and Q will be true, false, true, false. Now, our last column is going to be the conjunction P and Q. Now, the conjunction P and Q is true only when P is true and Q is true. Now, in our top row, P is true and Q is true, and therefore the conjunction P and Q is true. For our second row, P is true, but Q is false. But for the conjunction, they both need to be true, and they're not, and so the outcome there is false. Same thing for row 3. P is false, Q is true, but for the conjunction, we need them both to be true, so that condition is false. And of course, if they're both false, then the conjunction will be false. And we've completed our truth table. Let's take a look at another example. Let's look at these two simple statements. P, I have a car, so we can drive to Las Vegas. And Q is you have a car, so we can drive to Las Vegas. Let's create a truth table for the disjunction P or Q, because if we want to go to Las Vegas, it really only requires that one of us have a car to get there. So we'll start out the same way. We're going to make our table, and we need to have a P column and a Q column. And again, we're going to list all four combinations here where P will be true, true, false, false, and Q will be true, false, true, false. And that gives us every combination: true, 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 false, false, true, and false, false. Now the disjunction P or Q, that'll be true as long as one statement or the other is true. So for our first one, P is true and Q is true, and therefore the disjunction P or Q is going to be true. We both have a car, and so we can go to Las Vegas. Row 2, P is true, but Q is false. The disjunction is true since P is true. One of us has a car. Row 3, you have the car, so the disjunction is true. And for row 4, the disjunction P or Q will be true if either one of them is true, but in row 4, neither of them is true. That is to say, neither of us has a car, and therefore we are not going to Las Vegas, and we've completed that truth table. Now I'm going to give you one for practice, but let's look at one more that's a little bit more complex before we do that. Let's let P be the statement: I am smuggling Cuban cigars back from a trip to Canada, and Q is you are smuggling some Cuban cigars back from Canada. Let's make a truth table for the compound statement that would make a border crossing legal. And to be clear, it is not legal to bring Cuban cigars back from Canada. So we're going to start out the same way. We're going to have P and Q with all the same combinations. P will be true, true, false, false, and Q will be true, false, true, false. Now, we want to get to the compound statement that makes a border crossing legal. And I think that you would agree that it will be legal if neither of us are smuggling Cuban cigars from Canada. That is to say, it is not true that P or Q is true. That is to say, we do not want you or I to be smuggling Cuban cigars, but we can't quite build that column yet. Before we can build the column for not P or Q, we have to build the column for P or Q. In other words, we need to find out what conditions make this situation illegal before we can find out what conditions make it legal. So, row 1, both are true, the disjunction P or Q would be true. Row 2, P is true, Q is not, P or Q will be true. Row 3, P is false but Q is true, the disjunction requires one of them to be true, that row is true. But P and Q both being false, then P or Q is false. Now, the negation of that, the negation of P or Q, would be the exact opposite of P or Q. That's why we want to build this column first. It's an easy column, and then we can just reverse those to get the negation. So the negation becomes false, 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 true. Now remember, the goal was to make a truth table for the statement that would make a border crossing legal. Another way to say, not P or Q, it's not true that you or I are smuggling. And what condition makes a border crossing legal? This one right here. This is the only condition where it's not true that you and I are smuggling, and if we go back and look at our initial conditions, it means that these are both false. Neither you or I are smuggling Cuban cigars. Now, just to be clear, this is the only case that's legal, but we still need the whole table to look at all the possible outcomes. Okay, I'd like you to try this one for practice. Let the statement P be a Minnesotan is in possession of marijuana. Q is the Minnesotan has a prescription for medical marijuana. So create a truth table for the compound statement that would prevent this person from being arrested. It's a little bit of a tricky one, but give it a whirl. See if you can make that truth table and the compound statement, and unpause when you're ready to see the solution. Okay, let's take a look at this. First of all, if we want to make a statement that would prevent the person from being arrested, then we need to figure out what conditions will prevent them from being arrested. And in fact, it's true that you will not be arrested if either you don't have marijuana to begin with, or you do have a prescription. So on our two statements, P and Q, the condition that will prevent us from being arrested is either we don't have P, that is to say we don't have marijuana to begin with, or we have Q, which says that we have a prescription. So either we don't have marijuana or we do have a prescription. Now, we want to build that compound statement, not P or Q, but before we can build not P or Q, we need to have a column for not P. And now we can look at whether we have not P or we have Q. So these are the four columns we need this time. We're of course going to have P and Q, and we'll have our typical combinations here. But we need to have a not P column before we can determine whether not P or Q is true or false. So let's fill in the not P column. The negation of P will simply be the opposite of P. So since P is true, true, false, false, the negation of P will be false, false, true, true. And now we can fill in our not P or Q column. We're looking, do we have either not P or do we have Q? Well, in row 1, do we have not P or Q? Well, yes, that's true since we have Q. Row 2, do we have not P or Q? No, those are both false, so that condition is false. Row 3, do we have not P or Q? Yeah, in fact we have both, so that row is true. And row 4, do we have not P or Q? Yes, we have not P, so that row is true. So if we look at the outcomes here, what 3 conditions will prevent us from being arrested? We won't be arrested if 1, 3, or 4 is true. That is to say, condition 1, we won't be arrested because Q is true. We have a prescription. And 3 and 4, we won't be arrested because P is false. That is to say, we don't have any marijuana. The only case that won't prevent us from being arrested is row 2. And row 2 says that we do have marijuana, but we don't have a prescription, so it makes sense that that does not prevent us from being arrested. And we're done with our truth table. Now that's kind of confusing stuff. You might want to re-watch our first examples before we go any further and build more truth tables. Now let's create a few truth tables for various compound statements. Let's start with this one, not P or R. So we're going to start, since we have 2 simple statements, P and R, we're going to have a P column and we're going to have an R column on our truth table. And of course, we're going to have our 4 conditions, true, true, false, false, and we'll have true, false for R. Now we want to get to the point where we can build the given compound statement. Leave a bunch of space on your truth table because we need to progress to this point, but what we want to end up with is not P or R. So let's work backwards now. Before we can build not P or R, we need to figure out what the column not P or R looks like. We want to progress backwards till we're at just P and R. So in order to build not P or R, we undo that negation and just build not P or R. But we can't build not P or R yet because we don't know what not P is, so we need a not P column. And that'll do it. Once we know what not P is, or the negation of P, we can fill in the not P or R column, and then we can negate that to get our final column. Here we go. P is true, true, false, false, so the negation of P then has to be false, false, true, true. And the negation of P or R is then going to be the disjunction of not P or R. This is an OR statement, so we need one of these 2 to be true. Here R is true, so row 1 will be true. Here they're both false, so neither of them is true. Row 3, they're both true. That yields a true. And here R is false, but not P is true, and so the disjunction or OR statement is true. And now that we know what not P or R looks like, we can negate that to build not P or R. So true, false, true, true becomes false, true, false, and false. And we've completed our truth table. Now let's do another one, but let's look at a case where we have 3 simple statements to build off of. Here we go. Let's create a truth table for the compound statement not P or Q and not R. Notice that we have P, Q, and R here. We have 3 simple statements that we're going to build on. That's going to change the look of our table a bit. We're going to need a P column, a Q column, and an R column, but we're going to have more rows this time. We have more combinations to explore here. We're going to have 8 rows, and so P will have 4 true possibilities and 4 false possibilities. Then Q, we're going to follow a pattern here. It can be true, true, false, false, true, true, false, false. So for our first column, we have 4 trues and 4 falses. And then we pair them up. We have true, true, false, false, true, true, false, false under Q. And then R will be alternating true, false, true, false, true, false, true, and false. And by doing our entries in that pattern, we have every combination of true and false. Since we have 3 entries, we know that we're going to have 2 to the 3rd rows. If we had 4 entries, we'll have 2 to the 4th, or 16 rows. And there's one like that in your homework. Now let's look at our compound statement that we want to build. Again, leave plenty of room to work here. We want to end up building not P or Q and not R. Now let's work backwards and break this down into simpler statements. We definitely need to know what Q and not R are. So we'll make that a column. Let's have Q and not R. The other thing we need to know to fill in this last column along with Q and not R, we need to have a not P column. So let's build a not P column, or the negation of P. Those are the 2 columns we need to fill in the entries in our last column. Now, what do we need to fill in these entries? Q and not R, well, we have a Q column, but we don't have a not R column. So let's put in a not R column. And the negation of P, we can build that off of P. So this is everything we need. And again, to follow the reasoning there, we find out what the negation of R is and what the negation of P is. That allows us to build Q and the negation of R. Once we know Q and the negation of R, we can combine that with the negation of P to fill in this last column. Let's work this out so you can see what I mean. First of all, the negation of R, well, that's going to change all these trues to false and falses to trues. So we're going to have false, true, false, true, false, true, and false, true. The negation of P will do the same thing. The 4 trues become falses, and vice versa. Now we're ready to build the Q and not R column. This is a conjunction. We have to have both of these conditions true. So now we're looking at the Q column and the not R column. And in order to get a true entry, we need a true in both Q and not R. So Q and not R, no, we don't have both, and not R is false. So we'll have a false statement here. Here we have a true, and here we have a true, so row 2 is true. Row 3 is false. Row 4, we are missing our Q, so that one is false. Row 5, we have a true, but we have not R being false, so that's false. Row 6, we have true and true. That satisfies the and statement. They are both true. False, false, that's false. And false, true, no, we don't have them both, so that's false. Now that we have a Q and not R column, we can fill in our last column, our last compound statement here. And here we're checking the OR statement, the disjunction of not P and Q and not R. So we're checking this column right here and the not P column. And since this is a disjunction, an OR statement, we need either this or this to be true in order to get a true result. So false, false, neither of them are true. That's false. False and true, there we have a true. That one's false, neither of them are true. And here neither of them are true, so we have another false statement. And now all the rest will be true because we have a true for the negation of P for all of these. And we've built the truth table for this compound statement, not P or Q and not R. Okay, let's do one last example here with 3 simple statements. Let's let P be the fact that you remembered to bring your toothpaste on your trip. Q is the statement that you remember to bring your toothbrush on your trip. And R is you forgot to bring deodorant on your trip. So let's create a truth table for the compound statement that means you don't have to go find a Walgreens on your trip and get supplies. That is to say, we want to make a compound statement that says you remembered everything. Okay, so we're going to have a P column, a Q column, and an R column. And here again, we have 3 simple statements. 2 to the third is 8. We're going to have 8 rows. Following the same pattern, we're going to have 4 trues for P, followed by 4 falses. Q then will have a pair of trues and a pair of falses, and another pair of trues and another pair of falses. And R will then alternate from true to false, true to false. And again, we always do trues before falses. Now, what compound statement do we want to build? Well, we don't want to have to go to Walgreens. That is to say, we want to remember everything. And that means we want P and Q to be true. We want to remember our toothbrush and our toothpaste. But the other thing is that we do not want to forget our deodorant. That is to say, we want P and Q, and we do not want to forget R. So we need P and Q to be true, and we need R to be false. That is to say, we need the negation of R to be true. So what information do we need to build P and Q and the negation of R? Well, it looks like we need P and Q. We're going to have a column for that. And we're going to have a column for the negation of R. So let's do that. We're going to need a column that describes the conditions of P and Q, and we'll need a column that describes the condition of the negation of R. Once we know these, we can fill in the entries in our last column. Here we go. P and Q, we're looking at P and Q right back here. So P and Q both have to be true in order to yield a true result. This is a conjunction. So we're going to have a true, a false, and all the rest of these will be falses because we forgot our toothpaste for the bottom 4. Okay, now we need the negation of R. Remember, R is we forgot our deodorant, but the negation of R will mean we remembered our deodorant. So we're going to flip all of our entries in column R, and it'll become false, true, and so on. And that means we're ready to build our final column. We need the conjunction of P and Q, so we're checking this column. We remembered our toothbrush and toothpaste, and not R, that is to say we did not forget our deodorant. We need both of these to be true in order to yield a true result here because of our conjunction or and statement. So here we only have one true, that's not good enough. Row 2 we have both true. Row 3 is going to yield a false. Row 4 is false. And all the rest will be false because P and Q is false for the rest. And there it is. There's our truth table. So what has to be true so that we don't have to go to Walgreens? Row 2 is the only row here that meets all of our criteria. And if we go look at what the conditions were for row 2, P was true, which means we remembered our toothpaste. Q is true, which means we remembered our toothbrush. And R was false, which means we did not forget our deodorant. In other words, we remembered it. And there we go, there's our truth table. Okay, well that wraps up our introduction to truth tables here. We're not done with those. We're going to keep building truth tables, but we're going to add to their complexity in an upcoming lesson. A couple things to leave you with before we wrap this up. First of all, keep in mind the general structure of the truth table. When we have 2 simple statements, that means we're going to have 4 rows, and they need to be done in this order so that when we look at different truth tables, they're all exactly the same. They should have the same results. And so we're going to have true, true, false, false for our first simple statement and true, false, for our second. Our final compound statement should always be on the far right, and the slightly simpler compound statements that lead up to that should be in the middle. For a truth table based on 3 simple statements, we're going to have 8 rows, true, 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 false, 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 false for our first, and then breaking down from there. And again, our final compound statement, the one that we're testing, should always be on the far right, and the statements leading up to that should be in between. Now, you could have a truth table with 4 simple statements, and there would be 16 rows, or 5, and so on. And there's a little bit of work related to that in your homework. I'll leave you to think about that. But that wraps up this section. So make sure to let the folks at the Math Center know if you need some help, or let me know and we can work through a truth table or two and help you be on track. We'll continue this work and see you in our next lesson.